Hey guys, welcome back to another video. Today we're going to be making two things in one video. So the first thing is going to be really quick. So it's when it's proximity prompts. Okay. So you may not see it yet, but you'll see it when you play the game. Let's make its name explode. This is just how to make a little exploding part. But it's also going to be teaching a few more things. So script.parent.proximity prompt dot hold on. Not triggered. Connect function. Okay. So we'll go random. Now this is where we're gonna be teaching randomness, okay? Equals math.random 1 to 2. So this could be anything. It could be 1, a million, negatives, it can be anything. So then if random equals 1, so if it landed on the first one, it's a 50-50 chance now. And this just detects if the proximity prompt was triggered. So if random equals 1, then local explosion equals instance.new explosion. Now I'm sure you all know what explosions are. We showed them in one of my complaining videos, but basically it's just like those explosions built into Roblox. So explosion.position equals script.parent.position, and explosion.parent equals game.workspace. This is basically like making a new part. Okay, so then if random equals 2, then script.parent.anchored equals true. Script.parent. For I equals 1.100 do 0 script.parent.rotation plus equals vector 3.new 1 0 0 script.parent.position plus equals vector 3.new 0 1 0. And now let's spawn a few more of these and let's test it. Wait for it to load. Okay, those are just junk errors from the last video, ignore them. Okay. And that one flew off. That one flew off. And that one exploded. And then it flew off. Okay, so that's the random scripts for today. But the next part, I want to show something really complex compared to our usual stuff. Now it's on around the same level as our shop system, and what this is going to be is it's going to be a building system. Now it's not really going to have I'll add the grid system later in the video, but right now I'm just going to show you guys how to make a building system. So enter object tool place block. Now let's make our block. It can be 3 by 3 by 3. In fact, let's add in a little texture. So surface GUI. And you remember what these do from our last video on money. But if you don't know, they just display a GUI onto a part. Frame 1.1. And let's make it just script. BrickColor.random. Okay. Front, bottom, back, left, right, and then the top. So now let's run this real quick. See if it actually gives it random colors. And it did. Yep, so random colors all around it. And so let's name it brick. And we put in replicated storage. Now we take our place block part. We add in a new part, which will be the handle. So this is our first time using tools, I guess, other than the gun video and stuff. So let's add in our script. This is going to be a bit different. We're going to be using the same thing as the gun videos, where script and a local script and a remote function. Let's close all of these. Alright, so game.players.localplayer. Game.players.localplayer. Alright, no, we don't want to start with that. Script.parent.activate connect function E. Well, no E, I guess. So this will detect when it's activated. So local code equals game.players local player get mouse .hit .position script.parent.remote function invoke server code. So now you probably know what this will do. It'll tell you where your mouse is in a 3D space by detecting when the tool is activated. It will then set a new value as code, and this value will be the local player holding the tool, their mouse .hit .position in a 3D space. Then it will activate the remote function, and that remote function's code that will be put into it will just be the position. Now let's go into this script. Now script.parent.remote function.onServer invoke equals function player code. Now you probably know what this code already does. If not, I recommend you watch the gun video. What this stuff does. So let's get to coding. Local part equals game replicated storage brick clone. Part.position equals code. Wait, we don't want it just to be able to place anywhere. If code dot magnitude minus script.parent.handle.position.magnitude is larger than 50 or larger than 30, then else. So this from the magnitude is the sum of all the positions of a part and stuff, I think. Not quite sure. But if the brick's position is smaller than a certain distance from these, then it won't be able to place. So it's minusing the code's magnitude from the handle position.magnitude so that they can see how far it is. I'm not going to go too into detail here because this is going to be a long video already. But basically all you need to know is if you're removing a magnitude from a magnitude, that's going to be a distance. So part.position equals code. Parent equals game.workspace. Part. I think that's about it, actually. Yeah. Part.anchored equals true. Almost forgot that one. Alright. Let's add this into the starter pack. Let's play here. And now we do some testing and debugging. You know, those errors, those are junk errors. Let's place a part. And as you can see, it places. But you may notice something. They're kinda in the ground. And they're also kind of merging with each other. So, let's add a bit of extra code. So, plus vector3.new 0 dot part dot size times 0.5 dot 0. So part dot size dot y, so that will be its size up, and so it will have that and make that its position. So that's always halfway up, which will make it out of the ground. So let's test that real quick. And there you go. You can now place parts. But it still seemed to me emerging when you place them sideways. So how do we fix that? Let's add in a bit of extra code. This is where it's going to start getting complex, so if you don't want to stick along, you can just copy this code and put it in your game and start trying to figure out how it works your own, or watch how I said. But, okay. We'll go x equals part.position.x. We'll go z equals part.position.z. Now, we'll go true z equals math.floor z, right, for z. I'll go true x equals math.floor 4.x. So I'll add one for y real quick. True y equals that. True x, true y, true z. Now you may be wondering what this is. This is the x, y, z parts of the part positions broken down into individual values. Then the true will be the floor. So like the floor ceiling would basically be like if you had the, okay, let's say you have the value of 0.2. Now that would be closer to 0 than 1, so it would be the floor of that. But like, I'm not quite sure how it works. All I know is that it'll basically round it up to the closest number. Let's test it. And we do that for every value. Oh. We seem to still be having errors. Let's try to fix this. Four. It is 4 the size of the part. No, it was 3. Let's try to change that, see if that works. Okay. Huh. We still seem to be having a little glitch. Well, at the current moment, I'm not entirely sure as to what may be causing this glitch. However, I do know I'm probably not going to know how to fix it because I'm relatively bad at coding. So, let's just, unfortunately, revert this. Set this back to the way it was earlier. I'm sorry we had a bit of time wasted because I couldn't figure out how that code worked. But at least we got some working code, right? So now let's test it again. Alright, now you can place blocks, make little structures, and all entirely randomly colored and stuff. And we also still have our gun from the other video, which can lower health. Well, I hope you enjoyed that video. Please like and subscribe, and have a good day.